Hello and welcome to another video on the ContDataQC package for R. It's a guide video on the GetGageData function. I'm Zach Lepo, I work here at Tetra Tech. The ContDataQC pack is a package and add-in for R, which is a statistical programming language. The package enables the user to perform some quality control checks and related functions on their continuous monitoring data. The code, videos, and such will be available on GitHub, which is a code sharing website. Here's the link for the package, and then from there you can also link to the guides. The install for R commands is here from within R. You install DevTools and then use the install GitHub. Force equals true makes it so that you always get the latest version from the web. Build vignettes, true. They don't always build by themselves with this install GitHub, so this makes it so that they will. The vignette is a help file. As far as getting help from within R, always make sure you load the library first. Otherwise, R won't know any of the commands that are inside the package. Use the library ContDataQC. For help on a specific function, just prefix the function name with a question mark. And then you'll get a help window pop up. Help index for all functions, so that you can see all of them at once, is help package equals ContDataQC. If you want to see the vignette, which is actually a compilation of all the help files with a little bit extra text thrown in, there's the command. This particular video, we're going to focus on the GetGageData. There's a package that uses the USGS gauge data and downloads it. It does it through an implementation of the USGS R package data retrieval. One thing it does do is after it downloads the data, it reformats the data slightly for use with the ContDataQC package. Example code is library, question mark to get the help, or you can do vignette and get to the section on GetGageData and copy out the code there to follow along. Basic example is we name a gauge. We have to tell it the ContDataQC needs an operation, in this case GetGageData, site ID, picked out the gauge for Hubbard River. As with many USGS gauges, make sure you include that leading 0. Data I'm going to get is gauge. I've parameterized my selection type. Don't necessarily need to do that. Just if you're running lots of code, you can do that. My start date and end dates, I'm going to get January 1 of 2013 and December 31 for 2014. So I'm going to grab 2 years worth of data. As you can see, I followed the ISO standard for 4-digit year, 2-digit month, and 2-digit day. There's no import directory for this one, so I can leave it blank. My export directories, I used my base directory, which is get working directory that I specified in my code, and then selection of subdirectory that relies on a little bit of extra code that's in the example file, and then the ContDataQC where I just string it all together. To include a custom configuration, when you run ContDataQC, there's a parameter fun.myconfig, lets you set your own parameters. Say in this case, biggest thing would probably be if you're in a different time zone. The data retrieval package for R assumes that the data you're downloading is in the same time zone as what's on your computer. So say I'm working in East Tennessee and I'm downloading some data for a gauge that's in the Eastern time zone, I'm fine. But if say I'm downloading one from Memphis along the Mississippi, it's in the Central time zone, so I'm going to want to change my time zone in the configuration file. Otherwise, all my times will be off by an hour. An example using that same code I had previously, highlight the yellow, is I want to add in my configuration. I named the file config.tz.central, and if you want to know more about doing the configuration files, there's a different video and PowerPoint and R notebook. When you download the data, part of the report that you get back has the parameter codes, and if you're unfamiliar with the parameter codes, here's a website where you can look them up. And one thing is, part of the data retrieval package, it used to give you the parameter names, but this past summer they modified the package slightly so that it only reports back the codes instead of the names. So you have to be familiar that 60 is discharge, 65 is gauge height, 10 is temperature, water, in degrees Celsius, and 20 would be air temperature for degrees Celsius. The code does give you a little bit of on-screen feedback. It shows you a table of what data is available, how many records, and the time period. I also added in how many gauges that you request. You can actually request multiple gauges. Just concatenate them together with the C command in R underneath site ID. And it tells you how long it takes. So that way you know if you download the data and you walk away and come back, it'll tell you it took maybe 5-10 minutes if you're downloading like 10 or 20 years worth of data. And that's just dependent upon the data retrieval package. The download file format, it's saved into the specified directory. It's modified slightly so it looks like the other data files that are going to be used with the ContDataQC package. And the time to step into a little bit of live code is I have it saved as a R notebook, which is just a mashup of text and code chunks of R code that are then saved into a file. And then that's this file here on the screen. I'm using RStudio, and if I click my preview button, that actually comes up, saves it as an HTML file. And gives me who my author, dates. Here's a table of contents. So as I said, anytime you want to look at a help file, I'm going to go and look at the ContDataQC, and here's an actual example of getting gauge data. Before I run that, I actually want to run the top of the help file, where I have some parameters, some data directories, and even copy out a little bit of data to the computer so that I can use it. In this case, I've already run it a few times, so it's telling me the data already exists, and it didn't do any of the copies, file copies, because they already existed. Here's the actual link to the website for this gauge that I'm about to get data for. So I'm going to copy this data out and run that. And it takes a little less than a minute, but you can see here the site number, station name, Latin long, the datum that was used, the parameter codes, there's that 10, 20, 60, 65, the start and end dates for each one of those, so that you can see certain parameters have a longer record than others, and then you can actually get the count of the number of records. So it's already finished. If I wanted to, here where I specify the gauge, I could specify multiple gauges. Let's see, I'm not going to do it because it'll take a lot longer to download the data. Let's see, parentheses, each gauge in quotes separated by a comma, and then a closing parentheses, and rerun it, and I would get all that data. Like I said, if I want to get a different gauge, so I have here Mississippi River at Memphis, Tennessee. So I know this is in the central time zone, so unless I change the time zone, I won't get the timing will be off. So I'm just going to go ahead and run this. And there's not as much data for this one. Only 2 parameters, shorter time period on most of, so it takes a lot less time to download the data. One thing I can show you is I'd saved my configuration file here. I just clicked on it and it opened up, and everything I commented out, everything else except for my line for my time zone. So I changed this to America Chicago, so that's the central time zone. So I think that is all that I had to show for GetGageData. So you can retrieve as much or as little data. It actually retrieves all the data for that site with the continuous data. This does not download the daily values. You already summarized. So it downloads the data in a format that is most like what you would get if you were using your data loggers from out in the field. Let me switch back. PowerPoint. So there was my live code, and it's going to be saved on GitHub, that address. And I just want to acknowledge this work was done through EPA. Britta Beerwagen was our project manager. I'm Eric Leppo at TouchTech. Also at TouchTech is Jen Stamp, and then David Gibbs at EPA. Thank you.